Hello there, and welcome to The Sleepy Scientist. Tonight we drift beyond the familiar orbits of the inner solar system, beyond the warmth of Mars, beyond the giant planets, and beyond the distant blue calm of Neptune. Out here, sunlight grows faint, time feels slower, and space becomes wide and quiet. This is the outer edge of our solar neighbourhood, a peaceful region filled with ancient ice and slow-moving worlds. This is the Kuiper Belt, a gentle band of distant objects circling the sun in deep, silent space. Before we begin, allow yourself to settle comfortably. Let your shoulders soften, your hands rest easily, and your breathing slow down without effort. There is nothing you need to focus on, and nothing you need to remember. Whatever belonged to the day can fade quietly into the background, becoming lighter with each calm breath you take. The Kuiper Belt is not empty. It is filled with small icy bodies, faint dwarf planets, and quiet remnants from the early solar system. These objects travel along long orbits that take hundreds of years, moving so slowly that change feels almost still. Temperatures remain cold and steady. Light is gentle and dim. Everything out here seems patient, unhurried, and calm. As we continue, we'll explore the most relaxing facts about the Kuiper Belt. We'll observe how it formed, what kinds of worlds live within it, and how this distant region helps scientists understand the origins of planets and comets. These facts are not meant to excite or overwhelm. They are meant to slow your thoughts, ease your attention, and guide you gently toward rest. If you enjoy these calm journeys through the gentle side of science, you're always welcome to subscribe and return whenever you need quiet curiosity or peaceful sleep. But for now, allow your awareness to drift outward into the cold, quiet distance, where icy worlds circle slowly in the dark, and the solar system becomes calm and wide. Let's begin. The Kuiper Belt begins just beyond the orbit of Neptune, and what makes it feel so peaceful is the way it marks a quiet transition from the solar system we know into a region that feels almost untouched. Out here, the sun still shines, but its light is faint and gentle, like a distant lamp in a wide room. The Kuiper Belt is not a single sharp ring, but a broad zone filled with icy bodies that drift along slow orbits, and the calmness comes from the scale of time. A single orbit can take hundreds of years, meaning these objects move with an unhurried patience that feels almost still. The Kuiper Belt is made mostly of ancient leftovers from the early solar system, pieces of ice and rock that never became part of a major planet. In the first few million years after the sun formed, dust and gas swirled into a disk, and planets began to grow by gathering nearby material. In the outer regions, far from the sun's warmth, the ingredients included frozen water, methane, ammonia, and other ices. Many small bodies formed, but the growth of a large planet was slowed by distance, lower density, and the gravitational influence of the giant planets. What remained became a quiet archive, a frozen collection of early solar history still orbiting in the dark. One of the most relaxing things about the Kuiper Belt is how cold and stable it is compared to the inner solar system. Temperatures in this region are extremely low, often around a few tens of degrees above absolute zero. At such cold levels, many gases freeze solid, turning into hard ice that can remain unchanged for billions of years. This means that many Kuiper Belt objects preserve their original materials in a way that asteroids closer to the Sun may not. It is like a deep freeze storage space for the solar system, where ancient chemistry rests quietly, protected from intense sunlight and frequent collisions. The Kuiper Belt is home to dwarf planets, including Pluto, and this is one of the most calming ideas to hold in your mind because dwarf planets are worlds that are real and complex, yet distant and quiet. Pluto, for example, has a thin atmosphere that expands and collapses depending on its distance from the Sun, and it has smooth icy plains and mountains made of water ice. The fact that such detailed landscapes exist so far away in such dim light makes the Kuiper Belt feel like a gentle hidden world, where geology continues slowly and softly, without the rush of heat and weather we know on Earth. Many Kuiper Belt objects are locked into gentle gravitational relationships with Neptune, and these resonances are like quiet rhythms in the architecture of the solar system. Pluto, for example, completes 2 orbits around the Sun for every 3 orbits of Neptune. This keeps their paths stable over long periods, preventing close approaches that could disturb their motion. Resonances are like slow cosmic timing patterns that repeat reliably, giving the Kuiper Belt a sense of order. Even in a distant region filled with countless objects, motion remains structured and calm, guided by gravity's steady rules. The Kuiper Belt is one of the main sources of short-period comets, which are comets that orbit the Sun in less than about 200 years. What feels calming here is the idea that a comet's journey inward often begins as a very slow shift. A distant icy object can be nudged gently by gravitational interactions, sometimes with Neptune or with another Kuiper Belt body. Over long times, that small nudge can reshape the orbit, guiding the object inward. When it finally approaches the Sun, the warmth awakens it, turning its frozen surface into glowing gas and dust. But in the Kuiper Belt itself, before the journey begins, it remains quiet, cold, and still, like a sleeping traveller at the edge of the solar system. The Kuiper Belt is sometimes compared to the asteroid belt, but the difference is that the Kuiper Belt is much larger, much colder, and far more rich in ice. The asteroid belt lies between Mars and Jupiter, where sunlight is stronger and ice cannot survive as easily on the surface. The Kuiper Belt, by contrast, exists beyond Neptune, where sunlight is weak and temperatures are low enough for frozen materials to stay solid. This makes the Kuiper Belt feel softer and more distant, like a quiet extension of the solar system where the ingredients are gentler and the changes happen at a slower pace. There are different regions within the Kuiper Belt, and one of them is called the classical Kuiper Belt, sometimes known as the cold classical belt because its objects tend to have relatively low inclination orbits. These objects orbit the Sun in a calmer, flatter disk, and many scientists think they may be some of the most untouched remnants of the early solar system. Their colours can be reddish, suggesting complex organic molecules on their surfaces formed by long exposure to faint sunlight and cosmic radiation. The thought that these small worlds carry ancient chemistry on their icy skins, quietly aging in the dark, makes the Kuiper Belt feel like a peaceful museum of time. The Kuiper Belt is also affected by the history of the giant planets moving over time, especially in a process called planetary migration. Early in the solar system's life, the giant planets likely shifted their orbits slightly as they exchanged angular momentum with leftover material. Neptune may have moved outward, and as it did, it would have disturbed and rearranged many objects beyond it. Some objects were scattered, some were trapped into resonances, and some were pushed into stable zones. This migration was not a violent single event, but a slow reshaping over long periods, and it left behind the structured Kuiper Belt we see today. It is comforting to know that the solar system evolved through gradual motion, carving calm patterns into distant space. The Kuiper Belt remains difficult to observe directly because its objects are small, dim, and far away, and this itself is soothing. It reminds us that the solar system still holds quiet secrets, not because they are hidden on purpose, but because they are far and faint. Astronomers find Kuiper Belt objects by looking for tiny points of light moving slowly against the background of stars. Each discovery is like finding a grain of ice drifting in a vast dark ocean, and with every new object found, the Kuiper Belt becomes a little more familiar, not as a single ring, but as a wide, gentle region of frozen worlds moving slowly in the outer quiet of the Sun's domain. One of the most calming things about the Kuiper Belt is how softly it changes. In the inner solar system, worlds are shaped by heat, active atmospheres, and frequent interactions. Out beyond Neptune, the Kuiper Belt exists in a kind of deep freeze where time moves differently. Sunlight is so weak that many surfaces remain cold and stable for incredibly long periods, and the slow pace of motion means that even when objects pass one another, their encounters are usually gentle and distant. It is a place where the solar system feels quiet enough to hear its own long memory. Many Kuiper Belt objects have surfaces covered in a mixture of water ice and more exotic frozen compounds, like methane ice, nitrogen ice, and carbon monoxide ice. These ices behave differently depending on temperature and sunlight, and what feels peaceful is that in the Kuiper Belt they can remain solid and undisturbed for ages. Over time, faint solar radiation and cosmic rays can slowly change the chemistry of the topmost layers, producing darker reddish materials called tholins. This process happens gradually over long spans, and it creates subtle colour differences across these distant worlds without needing storms, fire, or heat. The distance of the Kuiper Belt also creates a unique kind of twilight. Even during day on a Kuiper Belt object, the sun would appear much smaller than it does from Earth. Its light would be faint, almost like a bright star rather than a blazing disk. Shadows would still exist, but they would feel softer, and the overall brightness of the landscape would be gentle. This dim sunlight gives the Kuiper Belt a soothing atmosphere, as if everything is lit by a distant glow rather than a harsh source, and it encourages the feeling that the outer solar system is a calm place of slow light and still cold airlessness. Some Kuiper Belt objects rotate very slowly, taking many hours or even days to complete a spin. Others rotate more quickly, but even quick rotation out there feels quiet because nothing is speeding through thick air or making sound. Rotation is silent, smooth, and steady. In the absence of an atmosphere, the sky remains black, even during the day, and the stars remain visible. This idea can feel deeply restful, a world turning slowly in silence, with faint sunlight on ice and an endless night sky always present above. Binary worlds are surprisingly common in the Kuiper Belt, meaning pairs of objects orbiting each other while together orbiting the Sun. These binaries can be close together or widely separated, and their orbits can be stable for billions of years. What feels calming is that these distant companions move in quiet harmony, like two small worlds bound in a slow gravitational dance. In some cases, the two bodies are similar in size, creating a balanced system rather than one large object dominating a tiny moon. This suggests the Kuiper Belt preserves gentle outcomes of early solar system formation, where slow collisions and gravitational captures created lasting partnerships. The Kuiper Belt also contains objects with unusual shapes, sometimes elongated or irregular, because their gravity is not always strong enough to pull them into perfect spheres. Some may be contact binaries, where two lobes are joined together, forming a shape like a snowman or peanut. These forms are quiet reminders that in the Kuiper Belt, creation can be gentle and incomplete in a beautiful way. Small worlds can exist in their own natural shapes, carved by slow assembly rather than forced into roundness by intense gravity. Collisions do happen in the Kuiper Belt, but they occur at a much slower rate than in the asteroid belt. The region is vast, and objects are spread out across enormous volumes of space. This means direct impacts are less frequent, and when they happen, they may involve slower relative speeds compared to inner solar system collisions. Even fragmentation is part of a slow cycle, producing smaller objects that continue orbiting quietly. The Kuiper Belt's wide spacing makes it feel like a calm open sea where encounters are rare and most bodies drift alone for long stretches of time. The concept of the scattered disk adds another layer of calm complexity. Some objects have stretched, elliptical orbits that take them far from the Sun and then bring them closer again, often shaped by Neptune's gravity in the past. These scattered disk objects can have long, looping orbits that take hundreds or thousands of years. Their paths feel like slow, wandering journeys across the outer solar system, moving through regions of space that are dim and quiet, sometimes spending most of their time far beyond the main Kuiper Belt before returning inward again, still silent and unhurried. The Kuiper Belt helps scientists understand how planets formed because it preserves the early building blocks that once filled the solar disk. When planets formed, they gathered material nearby, clearing their orbital zones, In the distant outer solar system, that clearing was incomplete, leaving behind a population of smaller bodies. Studying their composition and distribution is like studying the leftover ingredients after a slow recipe is finished. It tells researchers about the original mixture of ice and rock, the temperature conditions of the early solar system, and the gentle gravitational shaping that happened as the giant planets settled into their present orbits. One of the most soothing truths about the Kuiper Belt is that it remains a frontier, still full of unseen objects and quiet surprises. Even now, astronomers continue discovering new Kuiper Belt objects, dwarf planets, and binary systems. Each discovery is made not by loud signals, but by patient observation, by watching tiny points of light drift slowly against distant stars. The Kuiper Belt reminds us that the solar system is larger than we instinctively imagine, and that beyond the bright worlds we know, there is a wide, silent region of icy bodies moving calmly through space, holding ancient history in their frozen surfaces and continuing their slow orbits in the dark. The Kuiper Belt can feel deeply relaxing because it is a region where nothing needs to happen quickly. Out there, the solar system is not crowded, and the pace of motion is slow enough that change feels almost invisible. A Kuiper Belt object can spend centuries completing a single orbit, returning to roughly the same position in the sky only after many human lifetimes have passed. That kind of timescale makes the mind feel lighter, because it reminds you that the universe moves in rhythms far beyond stress or urgency, following calm gravitational patterns that never rush. One peaceful detail about the Kuiper Belt is that it represents a boundary between the familiar planetary system and the beginning of a wider, more scattered realm of icy bodies. Neptune is often thought of as the last major planet in the traditional sense, and beyond it the solar system becomes less like a neat row of planets and more like a gentle field of small worlds. This transition feels soothing because it is not a sudden edge. It is a gradual fading from order into open space, like walking slowly from a bright room into a quiet hallway where the lights become softer and the world feels more spacious. Kuiper Belt objects often have surfaces coated in complex ices that behave in calm, quiet ways at low temperatures. Water ice, methane ice, nitrogen ice, and carbon monoxide ice can remain stable, creating landscapes that do not melt or flow quickly. In such cold conditions, even the chemistry of the surface changes slowly. Over long periods, faint ultraviolet light from the sun and energetic particles from deep space can gently alter the surface molecules, creating darker and more reddish compounds. This slow, steady aging gives Kuiper Belt objects a kind of quiet patina, like ancient stones that have been resting undisturbed for billions of years. Many Kuiper Belt objects are very small, but their size does not make them simple. Even small bodies can have surprising surface features, like variations in colour and reflectivity, which hint at different mixtures of ice and dust. Some might have patches of fresher ice exposed by ancient impacts, while other areas may be darker and older, coated with radiation-processed material. The calmness comes from knowing that these landscapes are not being constantly reshaped. They change slowly, as if the surface is gently settling over time, holding its history rather than constantly rewriting it. The Kuiper Belt is home to dwarf planets beyond Pluto as well, such as Haumea and Makemake, and these worlds show that distance does not mean lifeless simplicity. Haumea, for example, is unusually elongated and spins quickly, likely shaped by a giant collision long ago. It even has a family of related objects with similar orbits, suggesting fragments from that ancient event. Makemake has a bright icy surface and may have a thin atmosphere at times. These distant worlds feel calm because even their more dramatic histories happened long ago, leaving behind stable orbits and frozen surfaces that now drift peacefully through the dark. Haumea also has moons, and the idea of moons in the Kuiper Belt is soothing because it suggests quiet companionship in deep space. Moons orbiting distant dwarf planets are held by gravity and long-lasting relationships, tracing paths that repeat over and over without sound. In the Kuiper Belt, the sky is always black, and yet these slow orbital motions continue, like a silent clockwork turning in the cold. Even far beyond Neptune, gravity creates stable dances that feel gentle and steady. The Kuiper Belt also contains objects with very low inclinations, orbiting close to the plane of the solar system in what feels like a calmer, flatter disk. These cold classical objects often have more stable orbits and are thought to have formed in place rather than being scattered around. Their orbits suggest they have remained relatively undisturbed since the early days of the solar system. This is calming because it means some parts of the Kuiper Belt may be like a preserved layer of the past, an ancient population still quietly circling the Sun in the same region where it first formed. Some Kuiper Belt objects may have very dark surfaces, reflecting only a small amount of the sunlight that reaches them. In the distant outer solar system, where sunlight is already weak, this creates worlds that are dim and shadowed. But this darkness is not threatening. It is simply the natural result of cold materials and long exposure to space weathering. The faintness feels restful, like a soft, dim room where nothing shines too brightly. It is a reminder that not everything in the universe is meant to be intense. Many places are quiet and subtle, existing without needing to stand out. Kuiper Belt discoveries often come from slow, patient scanning of the sky. Astronomers look for tiny points of light that move slightly between images taken hours or days apart. This slow movement is a sign that the object is within our solar system but far away. The process of finding these objects is calm by nature, requiring persistence, careful analysis, and long-term observation. The Kuiper Belt teaches the same lesson through its exploration as it does through its existence, that quiet patience reveals hidden worlds. Perhaps the most soothing truth about the Kuiper Belt is that it shows how the solar system never truly ends in a hard boundary. It fades outward into a region of icy bodies, and then into even more distant realms. The Kuiper Belt is like the solar system's quiet outer garden, filled with ancient frozen remnants, dwarf planets, and slow-moving companions. Everything out there continues in its gentle orbit, not needing to change quickly, not needing to be noticed, simply circling the Sun in the deep quiet, preserving the earliest materials of the solar system and drifting calmly through the cold darkness of space. The Kuiper Belt feels calming because it is a region where the solar system becomes wide and quiet, and where distance itself creates a natural sense of stillness. Out there, the Sun is no longer a powerful, warming presence. It is a small, bright point that gives just enough light to reveal the outlines of icy surfaces and dark skies. The faintness of sunlight means that everything moves slowly through long, cold seasons, and even the idea of weather becomes almost absent. The Kuiper Belt is like a gentle outer shoreline of our solar system, where time stretches out and nothing is in a hurry to become something else. One peaceful fact about the Kuiper Belt is that it contains objects with a wide variety of orbital shapes, and those orbits tell a quiet story about the solar system's early evolution. Some objects have nearly circular paths that keep them at a consistent distance from the Sun, while others travel along more elongated orbits that carry them inward and outward through the outer system. These differences often reflect how Neptune's gravity shaped the region long ago. Rather than chaos, the Kuiper Belt shows a calm structure, where even scattered objects follow predictable, repeating paths that can be traced with patience and mathematics. A soothing detail is that many Kuiper Belt objects have extremely long seasons. Because their orbits around the Sun can take hundreds of years, the slow progression from one part of an orbit to another becomes a kind of deep-time seasonal cycle. If an object has an atmosphere that changes with sunlight, those changes may take decades or centuries to unfold. Pluto is a good example of this, with its thin nitrogen atmosphere that can expand and collapse depending on solar heating. The calmness comes from the pace. Even when something changes in the Kuiper Belt, it changes so slowly that the universe seems to be moving in slow motion. The Kuiper Belt includes objects that may have layered surfaces, built up over time through gentle deposition of frosts and the slow transformation of surface chemistry. As these icy bodies drift through space, They're exposed to cosmic rays, faint ultraviolet light, and impacts from tiny dust particles. Over long periods, this creates a thin processed layer on top, often darker and redder than fresh ice beneath. If an impact exposes cleaner ice, the contrast can remain visible for ages. This is a calm form of geology, not driven by heat or pressure, but by subtle space weathering and time. Some Kuiper Belt objects may have internal heat sources, even at great distances, and this is a calming thought because it suggests quiet warmth can exist in the coldest places. Radioactive decay within rocky material can release small amounts of heat over long periods. In larger objects, this heat may be enough to keep parts of the interior slightly warmer than the surface, possibly allowing slow changes beneath the ice. These would not be fast or violent processes, they would be gentle, gradual shifts, like faint warmth stored deep inside a frozen world, moving slowly through layers over millions of years. The Kuiper Belt is also a place where we learn about how planetary systems form around other stars. Many stars are surrounded by debris disks, belts of dust and ice left over from planet formation. The Kuiper Belt is our local example of such a debris disk, and studying it gives scientists a calm reference point. It shows that forming planets does not mean clearing every small object away. Instead, planet formation can leave behind a distant belt of leftover material, a quiet reminder of the early disk that once surrounded a young star. The Kuiper Belt objects are often categorized by their orbital behavior, such as resonant objects, classical objects, and scattered objects. Resonant objects follow stable patterns tied to Neptune's orbit, like Pluto's 3-2 resonance. Classical objects tend to have more stable, less disturbed paths. Scattered objects have more elongated or tilted orbits, shaped by past gravitational interactions. What feels soothing is that these categories reveal a kind of order. Even in a region filled with countless icy bodies, there is structure and pattern. The Kuiper Belt is not random debris, it is a gently organized system shaped by gravity over long time. A calm and fascinating detail is that the Kuiper Belt is not very dense, even though it holds many objects. The space between individual bodies is enormous. If you were traveling through the Kuiper Belt, you would not see objects packed together. You would see vast emptiness, with distant icy worlds separated by millions of kilometers. This makes the Kuiper Belt feel like a quiet ocean, where the islands are rare and far apart. The emptiness itself becomes part of the environment, creating a sense of openness and stillness. The New Horizons spacecraft gave humanity one of its most peaceful glimpses into the Kuiper Belt. It flew past Pluto in 2015, revealing a world with icy plains, mountains, and a thin atmosphere. Later, it visited a smaller Kuiper Belt object called Arakoth, a contact binary that looks like two joined lobes. Arakoth appeared surprisingly smooth and ancient, shaped gently rather than violently. This visit showed that some Kuiper Belt objects have remained almost untouched since the early solar system, preserving their forms in quiet cold storage. Knowing that such ancient shapes still exist, drifting slowly in the dark makes the Kuiper Belt feel like a calm archive of creation. Perhaps the most soothing truth about the Kuiper Belt is that it teaches us the solar system's outer space is not empty, but softly populated by remnants of its birth. These objects do not compete for attention. They do not shine brightly. They simply exist, orbiting the sun in slow, repeating paths, holding ice, dust, and ancient chemistry in their frozen surfaces. The Kuiper Belt is a region of patience, where even discovery happens slowly, where time feels deep and unpressured, and where the solar system continues outward into a peaceful, quiet distance. The Kuiper Belt feels calming because it exists in a part of the solar system where light is gentle and motion is slow, and where distance creates a natural sense of silence. Out beyond Neptune, the sun is still present, but its warmth is faint, and its brightness is softened into something almost delicate. In that dim light, the Kuiper Belt becomes a quiet landscape of ice and ancient rock, with small worlds moving along long orbits that take centuries to complete. It is a region where time stretches wide, and the universe seems to slow down with it. One peaceful truth about the Kuiper Belt is that it holds material from the earliest days of the solar system, preserved in cold storage for billions of years. When the sun was young, a disk of gas and dust surrounded it, and small grains began to stick together, forming larger bodies. Closer to the sun, this process built rocky planets. Farther out, ices could survive, allowing different materials to gather into icy bodies. Many of these objects never became planets, but they remained in orbit as remnants. The Kuiper Belt is like the solar system's memory, carrying frozen pieces of its origin quietly through time. A soothing detail is how the Kuiper Belt helps scientists understand the building blocks of planets. Kuiper Belt objects contain mixtures of water ice, frozen gases, and rocky material, and studying them reveals what ingredients were available in the outer solar system during planet formation. Even without landing on them, scientists can measure reflected sunlight, using spectroscopy to identify surface components. This is gentle science, listening to faint light and quietly decoding it, learning about distant ice without needing to disturb it. Many Kuiper Belt objects have surfaces that have been slowly altered by cosmic radiation. Over long periods, energetic particles can break molecular bonds in surface ices and recombine them into more complex organic compounds. This process is slow and subtle, and it can darken the surface, sometimes giving it a reddish hue. The calmness comes from the time scale. This is chemistry happening over millions of years, like a slow aging process in deep space, turning simple frozen molecules into more complex coatings without heat, fire, or sudden change. The Kuiper Belt also contains objects that may have gentle internal histories. Larger dwarf planets can retain some internal warmth through radioactive decay in their rocky components. This heat can allow slow changes beneath the surface, such as the gradual movement of ice or the possible formation of subsurface layers with different compositions. These would not be fast or dramatic processes. They would happen gradually, like slow shifting beneath a frozen crust, making the Kuiper Belt feel quietly alive in ways that are subtle rather than active. One of the most peaceful features of the Kuiper Belt is its wide spacing. Even though there are countless objects, the region is enormous and the density is low. The average distance between objects is vast, meaning encounters are rare. If you could float through the Kuiper Belt, you would not feel crowded by worlds around you. You would mostly see open darkness and distant points of faintly lit ice. This emptiness creates an atmosphere of stillness, making the Kuiper Belt feel like a calm ocean of space, with scattered islands far beyond the reach of noise. Resonances with Neptune add another quiet layer of order to the Kuiper Belt. Some objects are locked into rhythmic orbital patterns, where their orbital periods form simple ratios with Neptune's period. These resonances create stable pathways that can last for billions of years, preventing close approaches that might disturb the orbits. Pluto's resonance is one of the most famous examples. This harmony in motion feels soothing, as though the outer solar system is guided by gentle timing, with gravity shaping stable repeating patterns rather than chaos. The Kuiper Belt also connects to the story of comets. Many short-period comets, which orbit the Sun in less than about 200 years, are thought to originate from the Kuiper Belt. These comets begin as quiet, icy bodies drifting in deep cold. Over time, a gravitational nudge can shift their orbit inward, guiding them toward the warmer inner solar system. There, sunlight awakens them, creating glowing comas and tails. But the calm part is where they come from, the long quiet years in the Kuiper Belt, where they exist in stillness before they ever become visible to us. The dwarf planets of the Kuiper Belt, like Pluto, Eris, Makemake, and Haumea, remind us that even far away, worlds can be complex. Pluto has mountains, glaciers of nitrogen ice, and a thin atmosphere. Eris is distant and cold, with a bright surface likely covered in frozen methane. Haumea spins rapidly and has a distinctive shape, hinting at ancient impacts. These worlds feel peaceful because they are distant and quiet, existing with slow rhythms, and their activity, where it exists, happens gently across long spans. Perhaps the most soothing truth about the Kuiper Belt is that it expands our sense of the solar system's calmness. It shows that beyond the planets, there is still structure, still meaning, and still history. The solar system does not end sharply. It fades outward into a region of icy objects, dwarf planets, and slow orbits. The Kuiper Belt is a quiet outer neighbourhood, holding ancient materials and slow-moving companions, reminding us that the universe is full of gentle places where time is deep, light is soft, and everything continues in steady motion without pressure or urgency. The Kuiper Belt feels calming because it is a place where the solar system becomes quieter, colder, and more spacious, and where everything seems to move with patient steadiness. Beyond Neptune, the sun's light grows faint enough that even the concept of daylight feels gentle. Shadows would not be harsh, and the sky would remain black with stars visible even when the sun is above the horizon. In this soft environment, the Kuiper Belt becomes a region defined not by activity, but by slow orbits, long seasons, and icy surfaces that change so gradually they seem almost timeless. One peaceful truth about the Kuiper Belt is that many of its objects are thought to be among the most untouched remnants of the early solar system. These bodies formed from the original disk of material that surrounded the Sun, gathering slowly in cold outer space. Because the Kuiper Belt is distant and sparse, many of these objects avoided the intense collisions and heating that shaped bodies closer to the Sun. This preservation makes them valuable to science, but it also makes them restful to imagine. They are ancient pieces of a beginning, still quietly circling in the outer dark, holding their early materials almost unchanged. The Kuiper Belt contains objects with surfaces made of different kinds of ices, and the cold temperature allows these ices to remain stable. Water ice is common, but so are ices made of methane, nitrogen, and carbon monoxide. These substances behave in quiet ways in such low temperatures, remaining solid and hard. In the faint sunlight, some of these ices can slowly sublimate, turning directly from solid to gas, but the process happens gently and rarely. Even when gas escapes, it does not create loud winds. In the airless vacuum, it drifts away silently, adding to the sense that nothing in the Kuiper Belt needs to happen quickly. Many Kuiper Belt objects are small enough that their gravity is weak, which means they often have irregular shapes. Unlike planets, which become round under their own gravity, smaller Kuiper Belt bodies can remain lumpy or elongated. Some appear to be contact binaries, formed when two bodies slowly came together and gently merged. This is one of the calmest images of formation in space. Instead of violent collision, it is possible that in the early solar system some objects met at low speeds and settled into one combined shape, like two pieces of ice pressing together softly over time. Binary systems are surprisingly common in the Kuiper Belt. Two objects can orbit each other while together orbiting the Sun, forming a quiet gravitational partnership. These binaries can reveal how Kuiper Belt objects formed, because the outer solar system's low-density environment makes certain kinds of captures and gentle mergers more likely. The peaceful part is the motion itself. Two small worlds circling one another in silence, tracing an orbit that repeats for billions of years, is like a slow cosmic lullaby, gravity shaping a rhythm that never needs to break. The Kuiper Belt also teaches us about colour in the outer solar system. Many objects appear redder than expected, not because they are warm, but because their surfaces have been altered by radiation. Over long periods, cosmic rays and ultraviolet light break apart simple molecules on the surface, allowing them to recombine into complex organic compounds. These compounds darken and redden the surface, creating subtle shades that vary from object to object. This kind of change is calm because it is slow, almost like a gentle aging process that happens quietly in deep space, leaving a soft record on the surface rather than a sudden transformation. A soothing fact about the Kuiper Belt is that it contains a region sometimes called the cold classical belt, where objects tend to have low inclination orbits. These objects travel in relatively flat, stable paths and are thought to have formed in place, avoiding major gravitational scattering. Because of this, They may be some of the most pristine examples of early solar system material. Their stability is comforting, suggesting that parts of the Kuiper Belt have remained quiet and undisturbed for billions of years, preserving ancient orbits like gentle tracks in the fabric of space. The Kuiper Belt is also connected to the history of planetary migration. In the early solar system, the giant planets likely shifted their positions slightly as they interacted with leftover material. Neptune's outward movement could have reshaped the Kuiper Belt, trapping some objects into resonances and scattering others into more distant or tilted orbits. This reshaping was not a sudden violent rearrangement, but a gradual process unfolding over long time. The calmness is in the scale and patience of it. The solar system carved its outer architecture slowly, leaving patterns and resonant rhythms behind. Spacecraft exploration has given us some of the most peaceful images of the Kuiper Belt. New Horizons revealed Pluto's landscape, showing nitrogen ice plains, water ice mountains, and a thin atmosphere that changes with seasons. Later it flew past Arakoth, a small Kuiper Belt object shaped like two joined lobes, ancient and gentle in form. Arakoth appears to have formed through slow, calm processes, likely assembling from smaller pieces that came together gently. This visit reinforced the idea that the outer solar system preserves quiet, ancient formation methods, and that not everything in space is shaped by violence. Perhaps the most relaxing truth about the Kuiper Belt is that it reminds us the solar system is vast and layered, extending far beyond the planets we learn first. The Kuiper Belt is a quiet boundary region, filled with icy remnants, dwarf planets, binaries, and slow-moving worlds. It is not an ending, but a continuation, the gentle outer neighbourhood where time stretches long and motion stays calm. In its cold darkness, the Kuiper Belt holds the memory of the solar system's birth, drifting quietly around the sun in steady orbits, as if the universe itself is keeping those ancient pieces safe and still in the deep outer night. The Kuiper Belt feels calming because it is a place where the solar system becomes soft and spacious, and where the energy of sunlight fades into something gentle rather than intense. Out beyond Neptune, the sun is still the same star, but its light is spread thin across a vast distance, arriving as a quiet glow rather than a strong warmth. In this dim region, icy bodies drift through silent space, moving along orbits so long and slow that even the passage of centuries feels like a small step in their journey. The Kuiper Belt holds a kind of deep time serenity, where everything continues steadily without urgency. One peaceful truth about the Kuiper Belt is that it represents a surviving portion of the original disk of material from which the planets formed. In the early solar system, small particles collided and stuck together, growing slowly into larger objects. Closer to the Sun, this process built rocky worlds, while farther out, cold conditions allowed ices to survive and gather into icy bodies. In the Kuiper Belt region, planet formation never fully cleared the area, leaving behind countless smaller objects. This makes the Kuiper Belt feel like a quiet record of the solar system's early ingredients, still circling the Sun as gentle remnants of its formation. The Kuiper Belt is not a single uniform ring, but a broad region with structure. Some objects are classical Kuiper Belt objects with stable, relatively circular orbits. Others are resonant objects, whose orbits follow simple ratios with Neptune's orbit, creating calm gravitational patterns that repeat over and over. Some are scattered objects with more elongated, tilted paths shaped by past interactions. This layered structure is soothing because it suggests order within the vastness. Even far beyond the main planet, gravity creates patterns, rhythms, and gentle categories of motion. Resonances with Neptune are one of the most calming features of the Kuiper Belt. Pluto is the most famous example, locked into a 3, 2 resonance with Neptune, completing 2 orbits around the Sun for every 3 Neptune orbits. This arrangement prevents close encounters and keeps Pluto's path stable over billions of years. Resonances act like slow cosmic metronomes, guiding the timing of orbits in a way that feels smooth and predictable. They show that the outer solar system is not chaotic debris, but a quietly balanced system shaped by gravity's steady design. A soothing fact about the Kuiper Belt is how rare collisions are compared to the inner solar system. The Kuiper Belt is enormous, and its objects are widely spaced. Even though there may be many bodies, the average distance between them is so large that direct impacts are uncommon. Most objects spend millions of years drifting alone, never approaching another closely. This creates an atmosphere of vast, calm emptiness, like a dark ocean where each island is separated by endless water. The space between bodies becomes part of the Kuiper Belt's quietness, making it feel open and still. Many Kuiper Belt objects have surfaces coated with a mixture of ice and dust, slowly altered by radiation and micro-impacts. Over time, cosmic rays and ultraviolet light can transform surface molecules into complex organic compounds, darkening and reddening the surface. Tiny dust particles can also strike, subtly changing the texture of the surface without creating dramatic craters. This is geology in the most gentle form, shaped not by heat and storms, but by long exposure to space itself. The changes are slow, steady, and almost meditative in their pace. Some dwarf planets within or near the Kuiper Belt have surprisingly complex surfaces, and this complexity feels calming because it unfolds without urgency. Pluto's nitrogen ice plains suggest slow glacial flow, moving like thick frozen rivers over time. Even though Pluto is cold, certain ices can behave like rock does on Earth, flowing and shaping landscapes under low temperatures. These processes are incredibly slow, and they happen in silence, making the Kuiper Belt feel like a place where geology continues gently, not as roaring volcanoes, but as quiet reshaping over millions of years. The Kuiper Belt also helps explain why comets exist. Many short-period comets likely originate from Kuiper Belt objects that were nudged inward by gravitational interactions. A small change in orbit can gradually guide an icy body closer to the Sun, where heat awakens it, releasing gas and dust and forming a glowing coma and tail. But before that transformation, the object spends long ages resting in the Kuiper Belt's cold darkness. This is calming because it suggests that even the brightest comet begins as a quiet frozen body, drifting peacefully at the edge of the solar system before slowly beginning its journey inward. The New Horizons mission gave humanity a rare, calm glimpse into the Kuiper Belt's true nature. When it visited Arakoth, a distant Kuiper Belt object, it revealed a world shaped like two lobes joined together, smooth and ancient. Arakoth appears to have formed gently, likely through slow collision or gravitational settling at low speeds in the early solar system. Its surface shows subtle colour variations and a quiet, undisturbed look. This visit was like opening a window into the earliest era of planet formation, seeing an object that has remained almost unchanged in the deep freeze of space. Perhaps the most relaxing truth about the Kuiper Belt is that it reminds us how much of the solar system exists beyond bright planets. It is a region filled with quiet worlds, dwarf planets, icy remnants, and slow-moving companions. It is not a place of constant activity, but of steady motion and deep time. The Kuiper Belt holds ancient materials and long-lasting orbits, circling the Sun in silence. In its cold distance, it offers a sense of calm openness, as if the solar system gently continues outward into a quiet frozen frontier where everything drifts slowly, safely, and patiently through the dark. The Kuiper Belt feels calming because it is a region where distance softens everything. Light becomes gentle, heat becomes almost absent. Motion becomes slow enough to feel like stillness. Beyond Neptune, the solar system quiets down into a wide, dark space filled with icy objects that do not demand attention. They simply orbit, taking centuries to complete a single loop around the Sun. When you picture that kind of movement, it naturally relaxes the mind, because nothing in the Kuiper Belt hurries, and nothing needs to happen quickly for the region to remain alive and meaningful. One peaceful truth is that the Kuiper Belt is not an empty gap, but a broad collection of leftover building blocks from the solar system's early days. In the ancient disk surrounding the young Sun, dust and ice slowly gathered into larger pieces. Closer in, this process created the inner rocky planets. Farther out, where cold temperatures allowed ice to remain stable, small icy bodies formed. Many never grew into full planets, and instead remained as a quiet population of frozen remnants. The Kuiper Belt is like a gentle archive of that early disk, preserving pieces of the solar system's origin in a way that is calm and steady. The temperature of the Kuiper Belt is one of the most soothing details to imagine. Out there, sunlight is weak and spread thin, and the surfaces of objects remain extremely cold. At these temperatures, many substances that are gases closer to the sun become solid ice. Nitrogen, methane, carbon monoxide, and water can all freeze and remain stable for ages. This creates a universe where materials feel quiet and unchanging. Ice does not melt, surfaces do not soften. Instead, everything remains crisp and preserved, as though the Kuiper Belt is a deep freezer holding ancient chemistry still. Many Kuiper Belt objects rotate slowly, and their rotation creates long cycles of faint daylight and deep darkness. In the absence of an atmosphere, the sky remains black, even when the sun is above the horizon and stars remain visible. This makes the Kuiper Belt feel like a place of constant night with a gentle distant lamp shining faintly. The softness of that light creates a peaceful mood, like a dim room where nothing is too bright and where silence feels complete. A calm and fascinating feature of the Kuiper Belt is how common binary systems are. Two small objects can orbit each other in a stable pairing held by their mutual gravity. These binaries can help scientists understand the conditions of the early outer solar system, because gentle formation and low-speed interactions make binaries more likely to survive. The restful part is the image of two distant icy bodies circling one another endlessly, moving in a quiet rhythm that repeats for billions of years without sound, like a slow gravitational lullaby out in deep space. Some Kuiper Belt objects appear to have very reddish surfaces, not because they're warm, but because their surface ices have been altered over time by radiation. Cosmic rays and ultraviolet light can break apart simple molecules and then allow them to recombine into more complex compounds called tholins. These molecules can darken and redden the surface, creating subtle colours that vary from object to object. The calmness comes from the slowness of this process. It is chemistry happening in silence, over immense time, leaving gentle colour signatures on frozen landscapes. The Kuiper Belt also contains bodies that are irregularly shaped, because their gravity is not strong enough to make them fully round. Instead of perfect spheres, many small objects are lumpy, elongated, or even shaped like two pieces joined together. These contact binaries are especially peaceful to picture, because they may have formed through gentle, low-speed mergers in the early solar system. Rather than a violent collision, it is possible that two bodies came together slowly and settled into one combined shape, like two pieces of ice pressing softly together and staying there for the rest of cosmic time. The influence of Neptune shapes the Kuiper Belt in calm ways through resonances. Resonant objects follow orbital rhythms that keep them stable over long periods. Pluto's orbit, for example, is protected by its resonance with Neptune, preventing close encounters. These resonances are like slow repeating harmonies in the outer solar system. Even though the Kuiper Belt holds countless objects, gravity creates patterns and pathways that are predictable and lasting. This gives the region a sense of quiet structure, like invisible tracks in the fabric of space. The Kuiper Belt is also connected to comets, especially short-period comets. Many of these comets may begin as Kuiper Belt objects resting in deep cold. Over time, a small gravitational disturbance can shift an object's orbit inward. When it approaches the sun, heat releases gas and dust, creating the familiar glowing tail. But what is relaxing is knowing that before any comet becomes bright and active, it is first a quiet, frozen body, drifting peacefully for millions of years at the outer edge of the solar system, unchanged and still. Perhaps the most soothing truth about the Kuiper Belt is that it shows how the solar system fades outward, rather than ending abruptly. Beyond the planets there is still structure, still history, still gentle motion. The Kuiper Belt is a wide, quiet neighbourhood of icy remnants and dwarf worlds, orbiting slowly under faint sunlight. It reminds us that the universe is full of calm places where time stretches long, where change happens gently, and where ancient objects continue their steady paths in deep silence, carrying the memory of the solar system's birth through the cold outer dark. The Kuiper Belt feels calming because it is a region where the solar system becomes soft and distant, and where everything is shaped more by time than by force. Out beyond Neptune, the sun's light becomes a quiet glow, and the warmth that drives storms and motion closer to the sun fades into cold stability. In this gentle environment, Kuiper Belt objects continue their slow orbits, moving with a patience that makes even centuries feel like a brief moment. It is a peaceful reminder that the universe often moves not in sudden changes, but in calm, steady cycles. One soothing truth about the Kuiper Belt is that it is one of the best places to study the solar system's earliest materials. The outer region of the young solar system was cold enough for many ices to survive, so small bodies formed with mixtures of water ice and frozen gases. Because the Kuiper Belt is far from the sun, many objects avoided the intense heating and frequent collisions that reshaped bodies closer in. This means Kuiper Belt objects can preserve primitive compositions, acting like frozen time capsules from the earliest era, holding quiet chemical clues about how the solar system was built. The sunlight reaching the Kuiper Belt is so weak that day would feel like twilight. The sun would appear small in the sky, and its light would spread gently across icy surfaces. Shadows would exist, but they would feel softer compared to the sharp brightness of Earth. This dim lighting creates a calming atmosphere. It suggests landscapes of ice, faintly illuminated, with long stretches of darkness where the sky stays black and the stars remain visible. The Kuiper Belt becomes a place where even daylight feels restful, where the cosmos seems closer because the sky never fully brightens. Many Kuiper Belt objects are covered in a thin layer of space-altered material. Over long periods, cosmic rays and ultraviolet radiation interact with surface ices, slowly transforming simple molecules into darker, more complex compounds. This process can create reddish tones, giving some Kuiper Belt objects surprisingly warm-looking colours despite their extreme cold. The calmness is in the pace. The surface changes happen over millions of years, with no urgency. It is like a quiet aging of ice under faint light, leaving gentle variations across distant worlds. The Kuiper Belt is rich in binary systems, where two objects orbit one another. This is soothing because it shows that companionship exists even in deep space. Some binaries are tightly bound, while others orbit each other at large separations, moving slowly through silent darkness. These systems may have formed when the solar system was young and crowded, and gentle interactions allowed pairs to remain together. Their long-lasting stability is comforting. It is gravity creating a steady rhythm, two icy bodies moving in quiet harmony for billions of years. Some Kuiper Belt objects may have rings or faint debris around them, showing that even small worlds can have gentle complexity. Rings in the outer solar system are not always dramatic, and they can be made of small particles of ice and dust that orbit quietly. If a ring exists around a small body, it suggests a past event like a collision or slow shedding of material. But what remains today is calm and stable. It is a reminder that even distant objects can have subtle systems of their own, moving softly in quiet balance. The Kuiper Belt also holds objects with surprisingly varied shapes. Some are rounder, shaped by their own gravity, while others are elongated or irregular, reflecting weaker gravity and gentle formation. Contact binaries like Arakoth show that some objects may have formed through slow merging rather than violent impact. Arakoth looks like two lobes joined together, smooth and ancient, suggesting a gentle assembly in the early solar nebula. This kind of formation feels peaceful, because it suggests that not all creation in space is explosive. Sometimes it is slow, quiet and soft. Neptune's gravity still influences the Kuiper Belt through resonances, shaping the orbits of many objects in stable patterns. Resonances act like invisible tracks, guiding objects into long-term stable routes that repeat predictably. Pluto is a famous resonant object, protected from close encounters with Neptune by its orbital rhythm. This structure is calming because it reveals a sense of order in the distant solar system. Even in a region filled with countless bodies, motion is not random. It is guided by gentle gravitational patterns that remain steady over time. The Kuiper Belt is the source region for many short-period comets, and this connection feels soothing because it shows how quiet beginnings can lead to bright appearances. A comet may spend millions of years drifting silently in the Kuiper Belt, cold and inactive. A small gravitational shift can eventually guide it inward. Only when it approaches the Sun does it become active, forming a tail. But the calm truth is that most of its existence is spent in stillness, in the outer cold, resting quietly at the edge of the solar system like a sleeping traveller waiting for a gentle change in orbit. Perhaps the most relaxing truth about the Kuiper Belt is that it reminds us the solar system is larger and more layered than we imagine. Beyond Neptune, beyond the last bright planet, there is still a wide, gentle region filled with frozen worlds. These objects do not rush. They do not shine. They move slowly through darkness, carrying ancient history in their ice. The Kuiper Belt is a quiet frontier, a calm boundary of our Sun's influence, where time stretches long, light remains soft, and the outer solar system continues in steady, silent motion. The Kuiper Belt feels calm because it is a place where distance creates quiet, and where the solar system becomes more like a soft boundary than a busy system of fast-moving worlds. Out here, sunlight is gentle and thin, spreading across ice without warmth, and the passage of time is measured in centuries rather than days. A Kuiper Belt object can drift through space for generations before completing a single orbit, and that slow motion makes the mind relax, because it suggests a universe that moves patiently, without urgency, guided by simple gravity and long, steady cycles. One soothing truth is that the Kuiper Belt helps explain the story of our solar system's early formation in the most peaceful way. When the Sun formed, a swirling disk of gas and dust surrounded it, and small grains began to stick together, becoming larger bodies over time. In the cold outer region, ice could survive and join this process, creating objects rich in frozen materials. Many of these bodies never grew into full planets, and instead remained behind as a distant population of icy remnants. The Kuiper Belt is like the leftover ingredients of creation, still orbiting quietly, preserving what the early solar system once contained. The Kuiper Belt is also a reminder that the solar system's edges are not sharp lines. It fades outward gradually. The planets end, but the debris does not. Beyond Neptune, the solar system continues as a quiet belt, then gradually becomes more scattered and eventually blends into even more distant reservoirs. This gentle fading is restful to imagine because it reflects how nature often works. It does not stop suddenly. It transitions slowly, becoming softer and more spacious as it goes, like a shoreline that stretches into open ocean. Many Kuiper Belt objects likely formed in place, meaning they were born in the same cold region where they still orbit today. These objects, especially the cold classical population, are thought to have relatively undisturbed orbits, and may represent one of the most pristine groups in the solar system. They move in a calmer, flatter arrangement, and their stability suggests they have avoided major scattering events. This is soothing because it means parts of the Kuiper Belt have remained quiet for billions of years, like ancient paths preserved in space, still tracing the same gentle loops around the Sun. Some Kuiper Belt surfaces may hold frozen nitrogen or methane that behaves like rock does on Earth, but in a much slower, colder way. On Pluto, for example, nitrogen ice can flow very slowly, forming smooth plains and gentle glacial movements over long time. This kind of geology is calm and silent. It is change without sound, motion without wind, reshaping landscapes over thousands or millions of years so slowly that nothing feels rushed. It shows that even in extreme cold, worlds can remain active in subtle, peaceful ways. The Kuiper Belt is a region where gravity is still the quiet master. Even though objects are small and far apart, gravity shapes their paths with precision. Their orbits remain stable, repeating the same slow patterns around the Sun for immense spans of time. Resonances with Neptune create even more structure, locking some objects into rhythmic timing that protects them from disturbance. This is calming because it suggests that even in the distant outer solar system, motion is not chaotic. It is guided by stable rules that keep everything in balance. A peaceful detail about the Kuiper Belt is how it connects to our understanding of other planetary systems. Many stars are surrounded by debris disks, belts of dust and ice that remain after planet formation. The Kuiper Belt is our local example of such a disk. By studying it, scientists learn how common it might be for planetary systems to have distant belts of leftover material. This creates a gentle sense of belonging, reminding us that our solar system is not unusual in having a quiet outer region filled with icy remnants, and that other stars may have their own Kuiper Belts drifting in calm darkness. New Horizons offered one of the most soothing views of the Kuiper Belt when it visited Arakoth, a small object shaped like two joined lobes. Arakoth appears ancient and undisturbed, with a smooth surface and subtle colours, suggesting it formed gently in the early solar system. Its shape supports the idea that some Kuiper Belt objects assembled softly, perhaps through slow, low-speed mergers rather than violent impacts. This is a calm picture of formation, showing that creation in space can be quiet and gradual, leaving behind delicate shapes preserved for billions of years. The Kuiper Belt also reminds us how much of the solar system is still being discovered. Many Kuiper Belt objects are tiny, dim, and difficult to detect. Astronomers find them by looking for slow-moving points of light against distant stars. Each new discovery expands the map of the outer solar system, revealing new worlds that have been there all along, quietly orbiting in darkness. This is comforting because it shows the universe still holds gentle surprises, waiting not for excitement, but for patient observation. Perhaps the most relaxing truth about the Kuiper Belt is that it feels like a calm outer neighbourhood of the Sun, where icy worlds and ancient remnants drift quietly in deep space. It is a place where light is soft, motion is slow, and time feels enormous. Nothing out there needs to rush or compete. The Kuiper Belt simply exists, holding frozen history and steady orbits in the dark beyond Neptune, continuing its silent circulation around the Sun as the solar system slowly fades outward into wider and wider quiet. As this quiet journey through the Kuiper Belt continues to drift gently through your mind, there is nothing you need to hold on to and nothing you need to follow. The outer solar system can remain wide and mysterious without needing your attention. Its slow orbits, its faint sunlight, and its frozen worlds will continue their calm motion whether you think about them or not. You may notice your thoughts becoming softer now, less defined, like distant points of light fading into a dark open sky. That is perfectly natural. The Kuiper Belt does not rush toward anything, and your mind does not need to rush either. Everything can slow down, everything can settle. Let your breathing remain quiet and unforced. Let your shoulders rest. Let your hands stay still. Imagine those distant icy objects moving patiently through space, each one circling the Sun in its own long, steady rhythm. Nothing out there demands effort. Nothing calls for urgency. There is only the gentle structure of gravity and time keeping everything in calm balance. The Kuiper Belt reminds us that the solar system is not just the bright worlds we know closely, but also the quiet regions beyond them. It is a place of deep cold and deep history, where ancient materials still drift in silence, carrying the memory of the solar system's earliest days. In that stillness, it becomes easier to feel safe, because the universe feels patient, steady, and unpressured. Thank you for spending this time with the Sleepy Scientist. Whenever the world feels loud or your thoughts feel heavy, you're always welcome to return. The universe will still be here, unfolding slowly, holding its quiet mysteries far beyond the planets, where the light is gentle and the motion is calm. For now, allow the silence to remain. Let the cold distance fade into comfort. Let the wide darkness feel peaceful, and let whatever comes next arrive naturally. Good night.